Good morning, it's October 9th, and this is your daily brief in science. Here's everything you need to know. A recent study from the universities of Cambridge and Oxford has revealed critical insights into the long-lasting symptoms experienced by individuals recovering from severe COVID-19 infections. Researchers utilized advanced 7 Tesla MRI scanners to identify brainstem damage, a factor that standard clinical MRI scans often miss. The study found abnormalities in key brainstem areas, such as the medulla oblongata, pons, and midbrain, which are essential for regulating breathing. These findings suggest a neuroinflammatory response that may persist for months following hospitalization. The researchers proposed that these brain changes likely stem from the body's immune response to the virus, rather than a direct attack by the virus itself. Participants in the study reported a variety of neurological symptoms, including headaches, brain fog, and psychological issues like anxiety and depression. Many also noted significant disruptions in their work or study routines, leading to financial strain due to ongoing health challenges. However, the study has limitations, primarily focusing on patients infected with the original COVID-19 strain and a predominantly white demographic. This emphasizes the need for further research that includes diverse populations. Dr. Sharon Stevelink pointed out the profound impact of post-COVID syndrome on daily life, advocating for comprehensive care that addresses both physical and psychological aspects of recovery. The research, funded by the Colt Foundation and supported by the National Institute for Health Research, sheds light on broader implications for other neurological conditions linked to brainstem inflammation, such as multiple sclerosis and dementia. Published on October 9, 2024, in the journal Arteriosclerosis, Thrombosis, and Vascular Biology, these findings highlight the significant global health implications of long COVID. A recent study published in JAMA Network Open has revealed a significant breakthrough in predicting treatment response and survival duration for patients with metastatic prostate cancer. This research highlights the role of circulating tumor cells, or CTCs, which are rare cancer cells released from tumors into the bloodstream. Traditionally, CTCs have been studied primarily in advanced cancer stages, but this study marks a pivotal shift in understanding their predictive value at the onset of metastatic disease. Conducted as part of a Phase 3 clinical trial supported by the National Cancer Institute, the study involved collaboration from multiple institutions across the United States. The primary goal is to enhance clinical trials by identifying patients who may benefit from more aggressive treatment strategies based on their CTC levels. Researchers utilized cell search technology to analyze blood samples from 503 men participating in a new drug trial. The findings indicated a clear correlation between higher CTC counts and shorter median survival. Specifically, men with 5 or more CTCs had a median survival of 27.9 months, while those with 1 to 4 CTCs had a median survival of 56.2 months. Remarkably, men with no detectable CTCs had a median survival exceeding 78 months. These results suggest that higher CTC levels signify a necessity for more aggressive treatment to enhance survival chances. Dr. Amir Goldkorn, the lead author, noted that this is the first study to assess CTC counts at the initial diagnosis of metastatic prostate cancer, providing critical information for distinguishing between patients with varying outcomes. Furthermore, Goldkorn's team is working on developing a new blood test to analyze the molecular composition of CTCs and tumor DNA, aiming to improve the predictive power for treatment matching. The research ultimately seeks to enrich clinical trials by identifying patients who would benefit from more intensive treatment strategies based on their CTC levels. Antimicrobial peptides, or AMPs, are gaining attention as a potential solution to the pressing issue of antimicrobial resistance, a problem that the World Health Organization has identified as a top global health concern. AMR is linked to over 60,000 deaths annually in the EU and the US, with estimates of up to 700,000 deaths worldwide. AMPs, which include a class of compounds known as bacteriocins, are produced by both gram-negative and gram-positive bacteria and play a vital role in fighting antibiotic resistance. The concept of AMPs is not new. It dates back to 1922 when Alexander Fleming discovered lysozyme. However, interest has surged recently due to the rise of multi-drug-resistant pathogens. These short cationic peptides, usually fewer than 50 amino acids, are present in all living organisms and are essential for defense against infections. AMPs work by disrupting microbial cell membranes through electrostatic and hydrophobic interactions, leading to cell death. Researchers are currently focused on optimizing these peptides by balancing their charge, hydrophobicity, and structural stability to enhance their antimicrobial activity while minimizing toxicity. Strategic modifications to the charge of AMPs have been shown to significantly affect both their effectiveness and safety. Bacteriocins, a specific type of AMP, are particularly noteworthy as they target specific bacterial pathogens, making them viable alternatives to traditional antibiotics. They can be classified based on the bacteria that produce them, with gram-positive bacteriocins being more common. Despite their promise, very few AMPs have successfully completed clinical trials, and only a limited number are currently available for patient use. A new study published in the journal Nature Aging indicates that humanity may have reached its biological limit for longevity, as average life expectancy appears to have plateaued. Over the 20th century, life expectancy in developed countries increased by approximately 30 years, but this growth has significantly slowed in the last 3 decades. Specifically, life expectancy at birth in the longest living populations has only increased by an average of 6.5 years since 1990. The study reveals that while more individuals may reach the age of 100, this will not significantly raise the average life expectancy. Lead author S.J. Olshansky points out that previous increases in longevity were largely due to successful disease combat, but aging now presents the primary barrier to extending life further. Researchers estimate that without significant medical breakthroughs, average maximum ages are likely around 87 to 90 for women and 84 for men. Olshansky argues that current medical advancements are yielding fewer additional years of healthy life, suggesting that the period of rapid increases in life expectancy may be over. Despite these findings, the study does not rule out future medical advancements but emphasizes a shift in focus towards improving the quality of life for older adults. The goal should now be to extend health span, which measures the number of healthy years lived, rather than merely increasing lifespan. Dr. Scott Kaiser, a board-certified geriatrician, highlights the importance of healthy lifestyle choices, such as maintaining social connections and being physically active, to potentially increase life expectancy. A balanced diet rich in leafy vegetables and phytonutrients is also recommended to promote healthy aging. Investment in geroscience, the biology of aging, is viewed as essential for future improvements in health and longevity. A new study has unveiled a significant advancement in food safety diagnostics. Researchers have introduced the first application of RPA CRISPR/Cas12a combined with lateral flow analysis for the detection of Shigella flexneri in food samples. This innovative integration allows for rapid and specific molecular detection without the need for complex instrumentation. The RPA CRISPR/Cas12a LFA system is designed for quick and portable identification of Shigella flexneri, making it particularly suitable for resource-limited settings. Field tests have shown the system's effectiveness with artificially contaminated food samples, achieving reliable results even at low concentrations. Remarkably, this new method has a detection limit as low as 8.3 copies per microliter of genomic DNA, demonstrating its high sensitivity. Current gold standard detection methods for Shigella require sophisticated equipment and trained personnel, highlighting the urgent need for simpler alternatives. The specificity of this system has been validated against 14 non-Shigella species, confirming there is no cross-reactivity. Combining high sensitivity, ease of operation, and cost-effectiveness, this method is poised to be ideal for food safety testing. Shigella is a major public health concern, being the leading cause of infectious diarrhea in China, with nearly 190 million annual cases and significant mortality, particularly in developing countries. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.